Now, let us try to answer this question on experimental techniques or experimental design, if you want. Now, a student wants to carry out an experiment to follow rate of reaction between hydrochloric acid and marble chips. This is marble chips, calcium carbonate, and this is hydrochloric acid. Now, you can see how to monitor a rate of reaction. Rate of reaction, we can monitor the rate gas is collected, rate of formation of carbon dioxide, or we can, if carbon dioxide escape, then we can say rate of decrease in mass. Decrease in mass. So we have two type of method to collect to monitor rate of reaction. Either we monitor the rate carbon dioxide is formed, is collected, the rate, the volume of carbon dioxide formed, collected, or decrease in mass because carbon dioxide is lost. This is liquid, this is liquid, this is a gas. So let us see the first one. The first one, carbon dioxide is collected by displacement of water. So this is correct. This one, carbon dioxide is lost from the reaction mixture. Carbon dioxide is lost. If carbon dioxide is lost, then the mass will decrease. So this is also a method, a technique to measure rate of reaction. This one is not correct because it does not record any volume of carbon dioxide involved or any decrease in mass. This is not correct. This is correct because we can collect carbon dioxide in the gas syringe. So the answer is 1, 2, and 4. 1, 2, and 4 correct, and this is not correct. Now let us see number 2. A diagram shows 4 pieces of apparatus that are used to measure volume of gas or liquid. Which piece of apparatus should always be filled with the same level? Same level. This is a good answer. Pipette. Why? Say for example, this pipette is 25 centimeter cube. We cannot use it to measure 20 centimeter cube. We can only use it to measure 25 centimeter cube. So this apparatus will measure only a fixed volume of gas, of liquid. This we can vary. Measuring cylinder we can vary. We can measure 10 centimeter cube, 20, 30, things like that. This also can vary. We can collect 20 centimeter cube of gas, 30 or 40 centimeter cube of gas, so we can vary. Here we can remove, we can collect, or we can put in a conical flask 20 centimeter cube, 15 centimeter cube, 21.5, any volume you want. Okay, so the answer, which apparatus should always be filled with the same level, so it is a pipette, 25 centimeter pipette used in titration. So this is these are the 2 answers for the first 2 questions. Now let us see this one. A gas is less dense than air and dissolves in water. Which diagram shows the correct method of collecting the gas? Now, this apparatus is used to collect a heavy gas. A heavy gas. The gas with a high molecular mass. So a heavy gas, example chlorine, HCl, These are heavy gases. Okay, so the gas will displace air, air will flow out, and it will be filled with the gas. This method is used to measure a, a gas which is less dense than air. For example, you have hydrogen or carbon dioxide, no, or hydrogen, or if you want ammonia, these are light gas. They are lighter than air. Okay. Now, this is not correct. This is a wrong apparatus. We cannot use this for any collection of any gas. Now, this one we can collect gas which are not soluble in water. Which are not soluble in water. Not soluble in water. Okay? If it is for example, carbon dioxide, oxygen, they are slightly soluble in water. So we can use this apparatus to collect them. Okay, hydrogen also we can use this apparatus. But we cannot use it for ammonia because ammonia reacts with water. We cannot use it for hydrogen chloride because it is soluble in water. So let us see the answer. A gas is less dense than air. Less dense than air, I think this is good. Answer B. Okay, because we cannot use this method. This is not good. We cannot use this method because it is soluble in water. Okay. Right. Now let us see number 4. Let's see this question. You can stop the video and try to answer the question. Okay, let us see. When heated, magnesium reacts with oxygen in air to produce magnesium oxide and a white powder. You know magnesium burns to form a dazzling film and a white ash is formed. Okay, and magnesium reacts with oxygen to form magnesium oxide. Magnesium oxide, 2 here and you have 2 here. So this is a white ash. A white ash. Okay. Now, a dazzling flame is for dazzling flame. Okay, is for when magnesium ribbon is burned in air. Now, what is the question? A student investigates the change in mass that occurs during the reaction. So this is not a good method. We cannot take a metal tongue, hold a magnesium ribbon and burn it because we are going to lose the mass. Because you are told it is given a mass, a balance. So for all these experiments, we can find the mass. And 3 sets of apparatus, which is wrong. This is wrong. This is a good method. We have here a small dish. This is open on both sides. Air enters, excess air moves out. So we can burn it completely. We allow it to cool, then we wait before and after experiment. This also. We can during the experiment, we can remove the lid, allow air to enter, then put the lid. We remove the lid, we heat it, it will react with oxygen. We remove the lid for a while, put the lid. Why we have to remove and put the lid? We prevent the white ash to move outside, to prevent loss in mass. Okay. Now, which set of apparatus suitable for this experiment? It is 2 and 3 or okay. Now look at this question. Stop the video and try it if you want. Okay. A student needs to measure 17.6 hydrochloric acid. choose commonly found in the school lab, which piece of equipment should be used to measure 17.6. Now we use a burette. A gas syringe is not good. A pipette you use for a liquid. A measuring cylinder is not precise. Okay, not precise measurement. So we use a burette. Look here, we have a burette. This is a burette. Can you see that with a burette we can measure 22, 22.1, 22.2, 22.3, 22.4. Here we have 27, 27.1, 27.2, 27.3. Okay, so we can measure it with precision. Okay, with a measuring cylinder also we can measure, but with the measuring cylinder it is not precise. Okay, so the answer is A. Now, let us see this. You can stop the video and try it. During the titration, what is the volume of acid used? So you take the final volume minus the initial volume. This is 27.3. 27.3. Okay, this is 27.3, and this is 22.4. 22.4 minus 22.4. Okay, 9, 10 minus 6, 9. Okay, the answer is 4.9. So this is the answer. Okay. Now the student, now try this question first. Stop the video and try it. A student has to measure 28.2 of sodium bromide. What is the piece of apparatus? You know, we can use this to measure 28.2, but it is not precise. In science, scientists need always tend to be precise. So we cannot use this. This we can use because it is precise, a burette. This we cannot use decimal place. Only 25 centimeter cube or 10 centimeter cube, depending on the size of the pipette. This is a measuring cylinder. We can measure 28.2 sodium bromide, but it is not precise. This is not precise, this is not precise. Okay, so we prefer to use a burette. Okay. Now, stop the video and try this question first. The formula of magnesium oxide can be investigated by heating magnesium, okay, in air to form magnesium oxide. Which apparatus is used to investigate this? Now, we have to weigh the crucible, the lid, and the magnesium powder. Magnesium powder. We take the crucible, the lid, we weight it. So we are going to put it on a balance. We get the mass of crucible, lid plus magnesium before heating. Then what we do, we heat it. We remove the lid momentarily to allow air to get in. Then we allow it to cool. Then we weigh it. We are going to find the new mass. Okay, so these two can be used. This one is not good. So the answer is 2 and 3 only. Okay. Right. Now we are going to do this. Number 1. Which of the apparatus ABC is used for measuring out a fixed volume of liquid? Fixed volume is a pipette. You cannot use this and you cannot use this. This is using titration, but we do not use it to measure fixed volume. So this is the fixed volume we are used to measure is 25 centimeter cube. So we use a pipette. Okay. Name the apparatus. This is a pipette. What safety item should be used? A pipette filler. A pipette filler. Okay. Pipette filler. Tell your teacher to show you a pipette filler. Okay, we use a pipette filler. Why is the safety item used? A pipette filler to avoid the solution, to prevent the solution from entering our mouth. Okay, to prevent the solution from entering accidentally in our mouth. Okay, now look at this question. Try to answer this. Very simple. What is the volume? Now the volume is 20. Can you see that here? 20, 20.1, 20.2, 20.3, 20.4, 20.5, 6, 8, 9, 10. So it is 25. It is 25, okay? 21, 22, 23, 24, 25. So the volume is 25. Okay? Now we are going to carry out with number 4. As usual, stop the video and do it. Which is the best apparatus for transferring 25 centimeter cube of a liquid from a conical flask to another titration apparatus experiment? So to transfer 25 centimeter cube, we use to measure a pipette. Okay, a pipette. Now, suggest which method XYZ is most suitable for collection of ammonia at HCl. Can you answer this question? Stop the video and try this question. So, ammonia. Ammonia is lighter than air, so we use Y because it is lighter than air. We cannot use water because it dissolves in water. So Y is the answer here. HCl is a heavy gas. So X is the displacement of air, downward displacement, and this is upward displacement. No, this is upward displacement because air will move out, will move up. Upward displacement, and this is downward displacement. Okay? So let me verify this. Now the apparatus shown below contains aqueous propanolic acid. The question is, name the apparatus. What is the volume used? The apparatus is a measuring cylinder. The volume is 20, 20.2, 20.4, 20.6. The answer is 20, 20, 24, 26 centimeter cube. The answer is 26 centimeter cube. Why? Because one division is 2. So it is 26. Okay. Look at this question. Try to answer this. Stop the video and try to answer this question. Okay. Read it first. A student add magnesium chloride to dilute hydrochloric acid. The temperature of dilute hydrochloric acid changes. A diagram below shows part of the thermometer stem before and after magnesium chloride. This is an exothermic reaction. Heat is released to the surrounding. So complete the table. Final temperature of acid is 35, 36, no, 35, 35.1, 35.2. So it is 35.2. Final temperature, final liquid 35.2. Initial temperature is 26, 27, 26, 27 here, 26.2.1.2.3, 26.3, 26.3. So we remove this 10, 10 minus 10 minus 9, cut this, cut with, okay, 8.9. Okay, it is 8.9. Okay, so the temperature, change temperature is plus, no, negative 8.9. Negative 8.9. 0. Okay, now we have 1 decimal place here, 1 decimal place here. So here also 1 decimal place. So you put negative because it is the energy released. So you are told to find the change in temperature. So I would prefer to put negative because to show that it is energy released. Or if you want, you might not put any temperature change here. Okay, any sign, because we don't know whether it is a molar quantity, how much magnesium we are using. Okay, now because negative and positive we put for exothermic and euthermic reaction respectively, but we don't know whether it is molar quantity. We put negative and positive only for molar quantity. So with which piece of apparatus should a safety bulb use? A safety bulb used. A pipette. We use a safety bulb. Okay, safety bulb is like that. It is like that. One safety here, like that. Bulb here, then here. No, here we put the pipette here. Put the pipette here. Okay. Then we press this one and then we press the bulb. It will suck the fluid. Then we press this one, the fluid will move out. Okay. This is okay. This you know. Now this one, 25 centimeter pure liquid, it is a pipette. Already seen this. The following apparatus is used in the lab. Okay. Write in the table the letter most appropriate purpose. Removing 25 centimeter of liquid. Removing 25 centimeter of liquid, we use a pipette. Okay. Measuring 60 centimeter cube of the liquid. Now, what is the BY? We cannot use the BY. 60 centimeter cube, we use E, the measuring cylinder. So you put letter E here. It has a titration flask. Titration flask is B, a conical flask. Separating a precipitate from a solution, we use D, and filter paper and funnel. Now look at this question. The student add a known mass of magnesium ribbon to 100 centimeter of hydrochloric acid. Of course, hydrogen gas will be formed, will be collected here. Now the question you give a test and observation for to identify hydrogen. Don't forget that hydrogen burns with a pop sound. It burns with a pop sound. Name the apparatus A and B. Conical flaws, gas syringe. What volume of hydrogen is collected in B? You have to read this volume. So it is 40, it is 50. The gas is with, so 46. It is 46 centimeter cube. Okay, now final question. Name the State the name of the apparatus. This is a beaker and this is a measuring cylinder. Okay, it's quite easy the questions. Okay, right. Okay, bye bye.